You know that specific kind of desperation when you're at home?
Mm-hmm.
Maybe you're in the back corner of the kitchen or trying to work from the patio, and you're holding your phone up to the sky like Simba on Pride Rock,
Yeah.
just trying to get one bar of Wi-Fi.
The universal signal hunt. We have all been there. It is a very, very humble moment.
Right. But then you contrast that with walking into a massive corporate office or a university campus.
Oh,
You
yeah.
get in the elevator, you walk through the lobby, you go down to the basement cafeteria, you cross a sky bridge to another building, and your connection is just flawless.
It never drops.
Never. It's like the internet is just oxygen. It's just there.
It really feels like magic.
Mm-hmm.
But as we usually find on this show, magic is just, well, it's engineering you can't see yet. And in this case, it's very expensive, very deliberate engineering.
And that is exactly what we are unpacking today. We've pulled together a comprehensive guide. It's titled Wireless Network Configuration, from SOHO to Enterprise.
Right.
And honestly, reading through the source material, it's like looking at the blueprints for two completely different universes.
It really is. We're going to trace the evolution of the infrastructure here. We're starting with that blinking box in your living room, the SOHO, or small office home office setup.
So,
And we're going to scale all the way up to the massive centralized brains that run enterprise networks.
and the mission for this deep dive is to finally understand the logic behind that shift. Because my first thought was, if I need Wi-Fi in a big building,
Yeah.
why can't I just go to the electronics store, buy 50 home routers, and tape them to the ceiling?
Please do not do that.
Well, that's what we're going to find out, why that fails and how the enterprise shift solves it.
It's a journey of scalability, security, and, honestly, physics. It's about moving from a device that tries to do everything all at once to a system where duties are split up, specialized, and centrally controlled.
So let's start with the familiar. Let's start with the SOHO. The guide calls this the Swiss Army knife approach.
Perfect analogy.
We're looking at a diagram of a standard Cisco Meraki MX64W day here. It looks like, well, pretty much every white plastic router I've ever owned.
Swiss Army knife is absolutely the perfect analogy. In a SOHO environment, your house, a small coffee shop, a dentist's office, you generally don't have a rack of servers humming in a refrigerated closet.
No,
You have one box, and that one box is an all-in-one solution.
it's pulling a lot of weight for a piece of plastic.
It is. I
Yeah.
mean, if you look at the architecture breakdown in the source material, this single device is actually performing 4 distinct jobs.
4 jobs.
Yeah, that in a big company would be 4 separate expensive machines. It's doing some serious heavy lifting.
Okay, so break that down for us. What are the 4 hats it's wearing?
So first, and this is the most obvious one, it's the access point.
Okay.
It has the physical radios and antennas broadcasting the Wi-Fi signal to your phone or laptop. That's the part we all interact with.
Right, hat number 1.
Hat number 2, look at the back of the device in the diagram. You see those yellow ports? It's a LAN switch. It's physically switching traffic for your wired devices, like if you plug in a desktop or a game console. It's managing all that local traffic.
Access point switch. Okay, what's next?
Third, it's the router. It's handling network address translation, NAT, and DHCP. So basically, it's the traffic cop assigning IP addresses to your devices so they can talk to the internet without crashing into each other.
And the 4th?
It's your firewall. It's the security guard standing at the perimeter trying to stop bad traffic from getting in.
Wow. That is a massive single point of failure.
Exactly. That is the beauty and the curse of SO. It's cheap, it's simple to deploy, you plug it in, and it basically works. But because everything is integrated, if that box overheats or the power supply dies,
Everything goes down.
your entire network, wired, wireless, security, it all goes dark.
Okay, so let's say I bought this all-in-one box for my small business. I plug it in. The guide has a section here called Initializing the Remote Site, Security First. And it seems like most people skip this part because they just want to get to Netflix.
Oh, most people absolutely plug it in and just hope for the best.
Yeah.
But the source lays out a 4-step protocol that's, well, it's pretty critical if you don't want to get hacked in the first week.
Okay.
Step 1 is standard access. You connect to the default IP, usually 192.168.0.1.
The classic address. I feel like I've typed that into a browser 1,000 times.
Which takes us to step 2, authenticate. And here's where I get nervous. The source points out that the default credentials are almost always
Let me guess. Username, admin, password, admin.
password or just blank. The guide explicitly states default credentials are public knowledge.
Oh, wow.
There are databases online. If you leave it as admin, anyone parked outside your house can own your network in like 10 seconds. They don't need to be a genius, they just need Google.
Which brings us to step 3, which is harden.
Yes. Change the password immediately. It sounds so basic, like digital hygiene, but it is the single most common vulnerability in these SOHO setups.
Now, step 4 caught my eye. Obfuscate? That's a fancy word. Are we, like, hiding the router under a blanket?
Digitally, yes, we're hiding the network structure. The guide suggests shifting the DHCP range away from the standard subnets.
Explain that. Why does it matter what numbers my IP address uses?
So hackers know that 99% of home routers use 192.168.0.x.
Right.
If they get into your network, that's the first place they scan for other devices to attack. So the guide suggests changing it to something obscure, like 10.50.0.x.
It's like moving your house number, so the mailman can find you, but the burglars get confused.
Ideally, yeah, it's called security by obscurity. It won't stop a determined pro, but it stops the automated scripts that are just looking for low-hanging fruit.
Okay, so we've locked the front door. Now we need to configure the actual signal. There's a screenshot here of the basic wireless settings, and there's a rule about channels that I think most people, including me, get wrong.
Ah, the 2.4 gigahertz rule. This is pure physics.
Yeah.
The 2.4 gigahertz spectrum is like a very narrow highway. And the lanes, the channels, they're not painted clearly. They bleed into each other.
So if I'm on channel 2,
You're crashing into the traffic on channel 1 and channel 3. You're causing a pileup. You're just creating noise that slows everybody down.
so what's the fix?
The guide is very specific. Use non-overlapping channels. In the US, those are 1, 6, and 11.
That's it. Just those 3.
Just those 3. If everyone on your street sticks to 1, 6, and 11, the signals can coexist without stepping on each other's toes. If you try to get clever and pick channel 4 just to be different, you're actually interfering with everyone on channels 1 through 6.
You're being the bad neighbor.
You are being the bad neighbor.
I am definitely checking my router settings after this. Okay, let's talk about traffic management. The guide mentions managing SOHO traffic and brings up QoS.
Quality of service.
Right.
Since this is an all-in-one box, the CPU's, it's limited. It has to decide who gets to go first when the internet pipe is full.
It's triage.
Exactly. The guide outlines a priority system. Priority 1 goes to voice and video.
Which makes sense. If my email takes an extra 2 seconds to send, I don't even notice. But if my Zoom call lags for 2 seconds?
It's a disaster. You look incompetent. So the router pushes email and web browsing to priority 2. It actively shuffles the data packets to ensure your VoIP call stays smooth, even if someone else is downloading a massive 4K video file. It's making smart decisions.
Okay, so that's the SOHO world. It's
Yeah.
self-contained, it's manageable for one person. But now, let's scale up. Let's go to the enterprise shift.
This is where the logic changes completely.
You mentioned earlier that we can't just chain home routers together. The guide asks, why? What is the actual breaking point?
It comes down to management and roaming. Imagine walking through that large office building we talked about. If you had 50 individual routers taped to the ceiling, they don't know about each other.
They're all just little islands.
Right. So as you walk, your phone holds onto the first router until the signal is totally dead. Then it drops, disconnects, stands for a new one, finds the next router, reconnects, gets a whole new IP address.
So someone on a call, the call drops.
Every 50 feet, it would be completely unusable. And plus, imagine the poor IT guy trying to change the Wi-Fi password. He has to log into 50 separate devices, one by one.
Nightmare fuel. So, enter the solution. The guide introduces the WLC topology.
The wireless LAN controller. This is the biggest conceptual shift in the whole document. We separate the brain from the body.
I love this analogy. Let's unpack it.
In the enterprise model, the access points, the things hanging on the ceiling, they're no longer smart routers. They are what the source calls lightweight access points, or LAPs.
So they're the body.
They're the body.
So they're just dumb terminals.
Essentially, yeah. They have radios and antennas, but no brain. Their only job is to catch the signal and tunnel it back to the brain, which is the WLC. The example shown is a Cisco Thur-Avo 4.
So the WLC is sitting in a rack somewhere in the basement.
Correct. And that one controller handles all the policy, all the security, all the configuration. You make a change on the WLC once.
And it goes everywhere.
And it pushes that change to 3,000 access points instantly.
That is the scalability we were looking for. And looking at the dashboard image for the WLC, wow, it's a little more complex than the home router page.
It's a network summary that gives you a godlike view of the entire environment. You can see the health status of every single AP. Green is good, red is trouble. You can see exactly how many clients are connected.
I see a docs there for rogues. That sounds ominous. Is that a hacker term?
It can be. A rogue is any unauthorized device broadcasting a signal. Let's say an employee decides the office Wi-Fi is too slow, so they bring in their own home router and plug it into the wall.
Ah, shadow IT.
Exactly. To the WLC, that is a threat. It's an unsecured backdoor into the network.
Right.
The WLC senses that new signal, flags it as a rogue, and alerts the admin. In some high-security setups, the WLC can even jam the rogue signal to kill it.
It's like having an immune system for your network. It attacks the foreign body.
That is a great way to put it.
Now, there's a diagram here called Anatomy of an Enterprise Connection. It shows how the signal actually moves. It mentions virtual interfaces mapping to physical ports. This feels a bit abstract. Help me visualize this.
Okay, think of the WLC as a massive sorting facility. When you create a Wi-Fi network, let's say corporate guest, that's a WLAN profile.
Right.
The WLC maps that profile to a virtual interface.
Okay, so a virtual lane inside the box.
Right, and that virtual interface is tagged with a VLAN ID, a virtual local area network ID, let's say VLAN 20 for guests. The WLC then sends that traffic out of a physical trunk port that connects to the rest of the wired network.
I've heard the term trunking before.
Think of the trunk port as the main exit door, but every single packet of data leaving it is forced to wear a color-coded badge.
Okay, I like that.
So, red badge for sales, VLAN 10, blue badge for guests, VLAN 20. The physical cable is carrying everyone mixed together, but the VLAN tags, the badges, tell the next switch exactly where that traffic is allowed to go.
And that's how you can have the CEO's secure Wi-Fi and the random guest Wi-Fi broadcasting from the exact same access point.
Yeah.
But they never touch each other.
Precisely. They are ships passing in the night, separated by those VLAN tags.
That is really smart. But for this to work, the plumbing has to be right. The guide has a section specifically on configuring the pipeline, VLANs, and DHCP.
This is where 90% of configurations fail. It's the subnets must match rule.
It sounds like a golden rule of networking.
It absolutely is. On the WLC, you define an IP address for the interface itself, say 192.168.5.254. That acts as the gateway, the way out.
Okay.
But then you have to set up a DHCP scope, the pool of addresses to give out to the clients.
Right, so I have my gateway. I need to give people addresses so they can find it.
But the math has to work. If your gateway is in the 192.168.5.x network, your DHCP pool must be in that same range. For example, pool start 0.69 to pool in 0.100.
And what happens if I, make a typo? Say I put the pool in 192.168.6.x.
Connectivity fails completely.
Oh, wow.
The clients might get an IP address, but they won't be able to talk to the gateway. It's like giving someone a house number on a street that doesn't exist. They're stranded.
I see.
The guide emphasizes this repeatedly. The interface IP and the DHCP scope must mathematically correspond.
Got it. Math matters. Now let's talk security. This is the other big differentiator. At home, I give my friends the Wi-Fi password. It's written on a sticky note on the fridge.
WPA to PSK, pre-shared key.
Right. But in an office of 5,000 people, you can't share one password. If one person gets fired, you'd have to change the password for the other 4,999 people.
Exactly. It's just unmanageable. That's why enterprise security moves beyond the pre-shared key. The guide introduces the security triad.
The triad. Sounds like a secret society.
It's the three pillars that keep the network safe: the WLC, SNMP, and radius.
Okay, let's break them down. We know that WLC is the controller, the brain.
Right. Then you have SNMP, Simple Network Management Protocol. The guide calls this the watchdog. It handles logging and traps. It's an alert. If an AP goes offline, or if that rogue device we talked about earlier pops up, SNMP is the system that notices and sends the alert to the admin console. It watches the state of things.
Okay, and the third one? Radius.
The gatekeeper. Radius stands for Remote Authentication Dial-In User Service. This is the server that holds the database of users. This is the key difference. When you log into Office Wi-Fi, you don't use a shared password. You use your username and your password.
So the WLC doesn't actually know my password.
No, and it shouldn't. That's a huge security risk. Yeah. The source shows a success flow diagram that explains this perfectly.
Okay.
You connect to the Wi-Fi, the WLC challenges you, you type your credentials, the WLC then encapsulates those credentials and passes them to the Radius server.
It's like the bouncer checking the list. The bouncer doesn't decide who's cool, he just checks the list from the manager.
Exactly. The Radius server checks its database. If you're valid, it sends an access accept message back to the WLC. Only then does the WLC let you in and assign you a VLAN.
And there's a specific technical detail here about how the WLC and Radius talk to each other. You have to trust each other first, right?
Correct. The diagram shows a shared secret. This is a password, but it's not for the user. It's a password just between the WLC and the Radius server, so they know the messages are authentic.
I see.
If that shared secret doesn't match, the Radius server ignores the WLC entirely.
And I see a port number circled here, 1812.
Port 1812. That is the standard UDP port for Radius traffic. If you're taking a networking exam, memorize that number. If your firewall blocks port 1812, nobody's logging in today.
Good tip. Okay, so I've got the brain, the body, the colored badges, which are VLANs, and the gatekeeper Radius. But let's be real. Technology breaks.
Always.
The guide has a troubleshooting methodology section, and I love visuals. This one is a funnel.
Yeah, the troubleshooting funnel is a great way to stay organized when the boss is screaming that the Wi-Fi is down. The guide suggests filtering the problem from top to bottom.
So what's at the top of the funnel?
The client. Always start with the client. Is their IP config valid? Are their drivers updated?
It's usually the user, isn't it?
I mean, 90% of the time. The guide mentions security mismatch. Are they trying to use WPA2 Personal, the home standard, on a WPA2 enterprise network?
Ah.
If their laptop is misconfigured, the best network in the world can't help them.
Okay, but let's say the client is fine. We move down the funnel to the environment.
Physics again,
Yeah.
distance from the AP obstructions. And there's a specific call out here for microwaves.
Wait, like kitchen microwaves?
Yes. Microwave ovens operate at nearly the exact same frequency as 2.4 gigahertz Wi-Fi. It sounds funny, but a running microwave leaks just enough radiation to completely destroy the Wi-Fi spectrum in the immediate area.
So if the Wi-Fi dies every single day at noon...
Check the break room. Someone is heating up a burrito and killing the internet.
That is incredible. And finally, the bottom of the funnel, the infrastructure.
This is the heavy stuff. Is the AP getting power over Ethernet? Is the cabling bad? Is the VLAN configuration on the switch port wrong? Is the WLC even reachable? You check this last because it's the hardest to fix, but also usually the most stable.
And underneath that funnel, there's a mention of the scientific method.
A brief but vital reminder. Identify the problem, form a theory, test the theory, plan the fix, verify the fix, and document it.
Document it. The step everyone skips.
And the step everyone regrets skipping 6 months later when the problem comes back.
Before we wrap up, there's one last pro tip in the optimization section regarding band steering. We talked about how crowded 2.4 gigahertz is, the microwave lane.
Right. Think of 2.4 gigahertz as the slow lane. It's crowded, it travels through walls well, which means high range, but it's slow. Fine for checking email.
Okay.
Then you have 5 gigahertz, that's the fast lane. It has lower range, it struggles with concrete walls, but it has huge speed and way less interference. It's perfect for video and VoIP.
So band steering is...
It's a feature on the WLC. The controller automatically identifies if a client device, like a new iPhone, is capable of 5 gigahertz. If it is, the network effectively steers or pushes that client onto the 5 gigahertz radio.
It forces them into the fast lane.
Yes. And crucially, it clears up the 2.4 gigahertz lane for the older devices or cheap IoT sensors that really need it. It's automated traffic control.
It really is impressive how much logic goes into that little Wi-Fi icon on our screens.
It is. We've gone from the SOHO Swiss Army knife, convenient but limited, to the enterprise centralized controller complex, secure, and truly scalable.
So taking a step back, what does this all mean for us, the people just using the internet?
I think the key takeaway is just an appreciation for the architecture. When you connect at home, you are the administrator, you hold the keys.
Yeah.
But when you connect at work, you are part of a massive living ecosystem.
Yeah.
A brain is managing you, a watchdog is logging you, and a gatekeeper is verifying you.
And that leads us to a provocative thought to leave you with.
We talked about the dashboard showing rogue devices. The enterprise network is designed to be all-seeing. It knows where you are by triangulating your position based on which AP you're closest to. It knows what kind of device you have. It knows how much data you're pushing.
So when you bring your personal phone to work and jump on the guest Wi-Fi because the cell reception is bad,
just remember, you aren't just connecting to the internet. You are entering a managed environment that is specifically designed to detect anomalies. Privacy in an enterprise network is a very, very different concept than privacy in your living room.
something to think about the next time you decide to check your social media from the office break room.
Indeed. Maybe stick to cellular data for that one.
That wraps up our deep dive into wireless network configuration. Next time you're in a big building, look up at the ceiling. Find that little blinking light, the lightweight AP, and give a little nod to the WLC hidden somewhere in the basement running the show. Thanks for listening.